Hey, Nathan here from PH Studios, and welcome back to another tutorial from the Tower Defense Engine series. And in this tutorial, we're going to discuss the last class, which is the map class. And after that, we'll do a final cleanup if we need to, and after that, I'll provide a looking back on the series and talk a little bit about that. Okay, so we have our writers and readers, just basically the same stuff we've done before. We write when we have like a string or anything simple. We write that. When we have more complicated stuff like a point or a integer array, we call write object. So we write that to our output, and that will create the XNB file. Remember, we're using the XML to have our maps and all of our content. We have XML for our maps and monsters and towers and all that stuff. So that takes what the XML has and converts it to the XNB file, which is the output. And you know what the get runtime readers do. It just converts the writer or reader to the assembly qualified name. And then we have all of our properties, which we coded in part 1. And then our money, whenever we set the money to value and change our money info string to the new money value. Okay, so all these properties and the public event handler new wave. Alright, so let's go ahead and get started with the methods. So the constructor is just going to do the basic stuff of initializing all the properties and fields. So we generate new lists, set the strings to empty, and set the wave index to 0. To world coordinates, we convert a tile point to world coordinates. Now, a point is a structure. It cannot be null. So what I do if it does not exist is it's -1 by -1, which obviously cannot happen in our game. We cannot have a -1 by -1 tile. You might in your game. But that's what I use to check if the tile exists or not. If it is a valid world coordinate or not. Okay, so now to set the x and y. The t.mapLocation.x times the tile dimensions.x plus tile dimensions.x divided by 2. And we'll do basically the same thing for the y. So what that is doing is, let's say we have a tile in location 1, 1. In my game, my tiles are 64 by 64. So, to world coordinates, instead of 1, 1, it's going to be 64 by 64. Plus the tile dimensions.x divided by 2. And we're doing that because we have our origin set up differently than the vector 2.0 location. The origin of our game is pointing directly at the center of every tile and every texture. So we need to add our origin to our result. So it'll be 64 plus 32. Alright, to world coordinates, we convert a integer x and y. To world coordinates, we do the same thing. X times tile dimensions.x, y times tile dimensions.y. Now, we don't say if we're converting a tile. This is converting a tile to world coordinates. Here, we're just converting a point to world coordinates. So we do not need to do any checking here. We don't know if it's used for a tile, a texture, or what. So we're just doing the default, what I have selected here. It's not adding the half of the texture. Because we don't know if it's going to be 500 by 500 texture or a 1 by 1 texture or anything in between. We just have a point x, point y. We just need to convert that to world coordinates. to map coordinates. So we have like 64 by 64. That will be 1, 1 at the end of this method. Okay, so for the update method, if the active wave is done, and if the wave index is greater than or equal to the last index in our list, we check to see if endless mode is enabled, which endless mode is not fully complete yet, but the code is here to do this check. If endless mode is enabled, we set the wave index is equal to 0. Otherwise, we set the state is equal to finish. Now, if the state does not equal finished, we set the wave delay. If it's greater than 0, we set the timer equal to wave delay, and then the state is equal to wave delay. And then we increment the wave index. We set the active wave to the new wave, and then we call the new wave event. Remember, this is all done if the active wave is finished. So this will only run once when we have finished an active wave. If an active wave is not finished and the timer is greater than 0, we go ahead and decrease the timer, and we use the singleton speed for that. If the timer is less than or equal to 0, we set the state to active if it is not already active, and then we update the active wave. Alright, so we start next wave now. We set the timer is equal to 0 and set the state to active. Okay, so this is the reset method. Remember, whenever you finish a map, the map is still in memory. It's finished in your memory. But whenever we go to the level selection screen and select the same map again, it calls a reset method. And it resets, it sets the wave index to 0, and it will do all this stuff. Is valid placement. That's the thing we used in the map region. We check to see if it's valid placement. Let's see here. Is valid placement right there. So this is the method that we're calling for, is valid placement. And we check to see if it is valid, if it is within the dimensions of the array, and it is equal to 0. That means it is a placeable. We can place something in that array. If it is not inside the bounds of the array, of course it's going to be false because we cannot place it outside of our map. Set valid placement. It's going to set the x and y coordinate in the array, and it's going to be 0 if the boolean is true, or 1 if the boolean is false. At the very beginning of our initialization of our game, it's going to generate the placeable array. So it's going to generate it based on the tile code, and we use the ground tiles and the path tiles. If the ground tile code is 0 and the path tile code is 0, and we are not within the spawn or castle location, it is a valid placement. Otherwise, it is not a valid placement. Okay, so this is the complex part, and this is the code that was going to take probably 5 parts of this class to talk about. I mentioned in the very beginning of the series that the map is responsible for loading everything. The map loader is responsible for loading the maps. So it starts with the map loader. The map loader loads each of the maps we have. Each of the maps load all of our monsters, our waves, and our towers. So this class is pretty much the master class behind loading everything, because we have all of our tiles, our arrays, our colors, the textures we want to use for our backgrounds, and all sorts of stuff. That's what the map is used for. We have a name for the map, the dimensions, the tile dimensions, description, the thumbnail for the map, and all this stuff. So just like any reader, we read, and if we have an object, we read the specific object we want. So we read object point to get the dimensions. Now I took this a step farther. If you do not have a thumbnail, it'll use the no thumbnail picture. Otherwise, it'll use the thumbnail we have set in the XML. Alright, now we load the tile sheet, asset, and in the tile sheet we use content.load texture 2D, and then we use the tile sheet asset. The number of tiles in sheet is going to be the tile sheet.width divided by the tile dimensions, and tile sheet.height divided by the tile dimensions. Ground tiles and path tiles, and then we get spawn location and castle location. Then we set the position based on the map spawn location.x times the tile dimensions.x plus the origin.x. And then we do the same thing for the y. Same thing for the castle. We generate the active tile path. And then we set the spawn rotation and castle rotation so they're pointing it to the appropriate spot. And we'll call the method getAngle between two map locations. And we get the adjacent tile location for that spawn and castle. Endless mode is a true or false. Now when we read a list, we call .addRange, and then we use input.readObject list of type string for the addRange method. So we have towers available. Now we need to generate a towers list. And here's what I said, that every map is going to be responsible for loading towers. It's responsible for loading waves. It's responsible for loading... Wave is responsible for loading monsters. But all this stuff you're familiar with, loading textures. I just checked to see if it's empty. If it is empty, it's going to throw an error sometimes. Right here, throw a new exception. The small normal button texture and the small error button texture must be the same size. So I do some checking and all that stuff. We generate the placeable array in the load method. Okay, so if the map.waveDelay is greater than 0, we set the state to wave delay and the timer to the wave delay. And then we get the song queue name, and then we return our map. Alright, generate placeable array. I've already discussed that. Get angle between two map locations. We have a point source and point target. Now we get an angle between those. And we use arctangent 2. The target.y minus source.y, comma target.x minus source.x. Get adjacent tile location. We have a map and then a point. So we need to find the adjacent tile location for the given point here. Now it's adjacent. So we look at the left, the right, the top, and the bottom. We don't look at the diagonal ones. We don't want the towers or the castle or spawn location to be angled diagonally. We just want it angled up, down, left, or right. So we offset the point.x minus 1, and then we do a for loop until it's plus 1. And if it's within the bounds of the map, we check to see if it's a passable tile. Now, a passable tile is for the monsters. So, if get adjacent tile location, we return that. Generate active tile path. Okay, we have a tile active path. a multi-dimensional array, and we initialize it by the tile dimensions.x, comma tile dimensions.y. We have two for loops for the x and y coordinates. We get the code for our path tiles. Remember, just like in the map region, we get the code, and then we generate a new tile, pass it the xy coordinates, and give it that code. Now, if code does not equal to 0, we set its type to passable. Else, type is equal to passable. Or not passable. And then we set the xy we set that in the multidimensional array to equal t. Alright, so this generates the active tile path. So we set map.activePath is equal to new path, AP, and then the start location, and then the castle location. Now what this does is it will generate a new path, and it will add every tile XY in the entries list. And then we'll set the start and end point. So we set the active path start to passable and end to passable. Then we generate the adjacency list. And after we do that, that will generate the adjacency list for our tiles. And here's a tricky part. After we generate the adjacency list, we calculate the shortest path, which is using a star. Okay, so the adjacency list is pretty... I restricted it as much as I could based on the tile's code. Now there's a few things that the designers, the graphic designers will need to be aware of whenever you're designing your own map. If we go to the finished game and let's go to a vector and look at the tiles. That's really not a good example. Let's go to the snow and look at the tiles. Okay, here we go. This horizontal tile, this is a horizontal tile. That cannot be adjacent to a vertical tile. It can only be adjacent to this tile, any of these tiles here. But I took that a step farther. So what I did here is I checked to see if the tile code is 0, or 6, or 8, or 9. Then we add to adjacency list the row -1. So if we look at our finished example here, 0 is pretty much in all of these, so we don't need to worry about that. So let's 6. 0, 1, 2, 3, 4, 5, 6. So if it's 6, 8, or 9, we add an adjacency tile that's in our left. This tile has connections. A tile of code 6 has a connection from the left to the right. It's a horizontal tile. You can only have a connection to the left and the right. You cannot have a vertical connection to a horizontal tile. That doesn't make any sense. Just like this vertical tile here. We cannot connect a horizontal tile to a vertical tile. You just cannot do that. So, if the tile code is 6, we accept a connection from the left and the right. If it's 7, we accept a connection from the top and the bottom. If it's 8, we accept from the left and the top. Remember, it's curved. Left and the top. You can pretty much tell what I'm doing here. There's going to be a passable tile here and a passable tile here. If we're looking at this tile there. So that's what we are doing in this example here. Whenever we want to add an adjacent tile that's to our left, we need to filter it based on the tile codes. So 0, 6, 8, 9 can accept adjacent tiles to their left. A vertical tile cannot accept an adjacent tile to the left. So it's an A-star algorithm, but severely reduced in the adjacency list, so it's extremely fast compared to a full map and its adjacency list in there. Hopefully this makes sense. For any given tile, they have 2 connections associated with it. Now, if you want to make a tile that is a cross that can accept all 4 connections, that's fine. You'll just have to add it in the code here. But for my game, every tile here has 2 connections associated with it. This is a horizontal tile. The monsters are traveling horizontally. So we only have a connection on our left and our right. We cannot add a vertical tile to this and connect them. Look there, it's blocked in between the 2. So we cannot have a vertical connection next to a horizontal connection unless you make a cross tile. So that's what this loop is doing. Alright, so we get the tile, we check to see if it's within range. If it's not within range, like this tile accepts connections to our left. But if we are at the very left side of the map and we go left again, we are in the negatives and that's not within the range, so we return null. Else, we get the tile from the row and the column. If it is a passable tile, which means the monster can travel on it, we return the tile. Else, we return null. So we have a severely restricted A-star. If you look at the thumbnail for any of the maps that I created, I show you what it looks like. I take a snapshot of the map and I show you what it looks like. Now, if you see my A-star algorithm, you know how complicated it can be and how massive the adjacency list can become and how massive the algorithm can be. Now, for this, we have a set path. Going from the start, they go here a little bit, and then they go to the end. Now, instead of having every single tile in our game part of the A-star algorithm. Because if we do that, it's going to say, oh, the shortest path is from here to here. If we had every single tile in the adjacency list without any restrictions, the game would say, without us doing any checking, of course, the game would say this is the shortest path. Instead of doing it this way. My screen drawing is horrible, I apologize. Instead, we are only adding the start and the end and every passable tile. Remember, a passable tile is the tile that monsters can travel on. Only these are added to the adjacency list. So even though we have a set path, and even though we're using A-star to generate that path behind the scenes, it's going to generate the same path we have already created. Why is it doing that? I don't know. It's going to generate the same path we have already created. It just makes it easier on us to have A-star take care of it. Okay. The reason why it is a good thing to have A star take care of it for us, because it'll make things easier. I had the A star algorithm already finished from my video. All I had to do was add that to the path class, and that was it. The A star algorithm already positions the tiles in a hierarchy. So if you're on this tile, the next tile in the list is this, and then the next tile after that is this, then the next one, and then the next one. It already does that for us. It already prioritizes the tiles for us. So it'll automatically prioritize and orders the tiles from start to finish automatically. Okay. So, now, that is it for this class, and that is it for the engine series, and we might do a couple of cleanups. But for now, that is it for this video. I hope you enjoyed it, and I hope I discussed the A star and the adjacency list and how that works enough, and I hope you understand that. So I hope to see you next time for a cleanup. If we don't have anything to clean up, I'll see you next time for looking back on the series. So thanks for watching, and I hope you enjoyed.